will discuss another situation where work is done and we will analyze the case and apply to the standard equation. Let me read the problem which is given as example 4.5 in the book. A weightlifter lifts a mass of 250 kg with a force 5000 Newton to the height of 5 meters. This is the situation. A weightlifter is lifting a mass 250 kg. He is using a force of 5000 Newton. That is the force given by the lifter, and he is taking it to the height 5 meters. This is what is the situation given. Now, what is asked in this? What is the work done by the weightlifter? So, in lifting the weight, he is doing the work. So, how much work he is doing? Second, what is the work done by the gravity? So, as he lifts, he is giving a force and lifting it, and the gravity will also be acting on the mass 250 kg because it is going up, and the gravitational pull will also be there, force of gravity will be there. So, what is the work done by the weightlifter and what is the work done by the force of gravity? Because in this process, both these forces are acting on the object. So, individually they are asking us to calculate the work done. And the third one, what is the net work done on the object? So, let us go and recollect our formula. So, the work done is equal to F cos theta dr. So, usually F cos theta dr. So, let me just take. So, that is how we go about using the formula. If you want F cos theta to be a constant force, we can take it out. Integration between initial position to final position dr. When you integrate it, it is the displacement again. Therefore, I am directly writing the work done to be F cos theta dr. Let us see what is our first case. Work done by the weightlifter. So, now let me just put the weightlifter L, by the lifter. So, the one who lifts the weight. So, which is equal to force given by the weightlifter cos theta and dr. So, in this case, this is the force given by the weightlifter. So, which is equal to 5000 Newton, and theta is the angle between the direction of force and the direction of displacement. So, when the lifter lifts the weight, how is he going to lift? From this ground level, he will lift it to some height. It is he is lifting it up to 5 meters. And therefore, this is initial and this is final. So, the displacement dr is equal to 5 meters. And what about theta? Theta, he is lifting in this direction and the object is also moving in this direction, and therefore, theta is equal to 0 degrees. So, cos of the angle is equal to 1. So, now do we have all the parameters? Yes. So, identifying the situation, we have got all these values. Let us substitute. So, the work done by the lifter is equal to, substitute for the force directly given and cos of the angle is given, and the displacement is given as 5 meter, which is 25,000 joules. 25,000 joule can also be written as 25 kilojoule. That is the answer for the first question. So, now what is the second question? Second question says, what is the work done by gravity? So, as he lifts the weight, so for work done by gravity is F due to gravity cos theta dr. So, when he lifts it, so the same situation from the ground level, it is lifted up to 5 meters, but as he lifts, mg will be all along acting in the downward direction. So, he is giving more force and lifting it up, but at the same time mg will also be acting, but in the downward direction. So, in this situation, mg is acting in this direction, force is in this direction, and the displacement, in spite of that, because he is giving more force, it is going in the upward direction, and therefore, theta is opposite direction. So, in this case, theta is equal to 180 degrees and cos 180 is equal to minus 1. And what about displacement? So, displacement again in the same process, both the forces are simultaneously acting, and therefore, the displacement would be the same as the previous case, and so dr is equal to 5 meters. So, substitute, so work done by gravity is equal to, only thing is now gravity is giving. So, what is Fg? Fg is equal to, due to gravity, mass mg cos theta dr. So, substituting, so is a mass given? Yes, mass is given as 250, and therefore, 250 into g is 10 cos of the angle minus 1, and the displacement is same 5 meters. So, now the value happens to be 12,500 joule, which can be written as 12.5 kilojoule. So, we have got the answer for the second case, work done by gravity. Remember, both are acting on the object, all the time it is being lifted up. And so, what is the net work done on it? So, the net work done is equal to, so the net work done is net work done is equal to work done by the lifter plus work done by gravity. So, by the lifter is 25 kilojoule and by gravity is 12.5, which is with a minus sign, and therefore, 25 minus 12.5 is 12.5 kilojoule. So, the lifter has given excess force, or he has transferred this much, he has done so much of work done, and that is the reason, even though the gravity was acting on this 250 kg weight, he was able to lift it through the height of 5 meters. So, in this case, the work done, net work done is in this case, the total work done is 12.5 kilojoules, which is positive.